Hey, this is Mr. Easton with Homework Help. We're going to talk today about an area model for multiplication. This could be used in 4th or 5th grade, maybe even 3rd grade, depending on what skills your 3rd grader has. I think that the model I'm going to show you has been kind of getting some popularity on Facebook and other video sites, and with mixed reviews. Some people really understand it, and some people, are making videos about how they can go make a cup of coffee while this strategy is being done. So I wanted to talk about the strategy a little bit. I think the point that's lost here is that teaching this model is not the end-all be-all for multiplication. This is a model that we want students to understand how it works, because it kind of helps understand how the algorithm works, and then they can move into some of those other algorithms, and then maybe even not using an algorithm at all, but use a different strategy. So I'm going to talk about 3 different ways to solve this question, and we're going to kind of look at how the progression works between the 3. Alright, so this is an example of what a concrete model would look like for 22 times 12. What we've got up here on the top in the sides are our linear pieces. That's kind of indicating our multiplication question. So across the top over here, you've got your 10 and your 1, 2 for 12. On the side, you've got your 10, another 10 for 20, and a 1 and a 2 for 22. And so we're modeling what 12 times 22 looks like. And so we're going to take it piece by piece here. We're going to look at this 10 times this 10, which is 100, which is why our yellow piece is here. This 10 right here times this 1, which is 10 times 1 is a 10. We've got this 10 times this 1 over here, which is a 10. We've got this 10 here on the left times the 10 on the top, which is another 100. We've got this 10 times this one and this one for 10 and 10. Down at the bottom, we've got a 10 on the top times each of our 1s here, which is a 10 and a 10. And then we've got each of our 1s times each of our 1s. So that's 4, 1 times 1, which is 1, 2, 3, 4. And so our answer comes from adding up what our yellow pieces are. And so we'll go ahead and write that out now. We've got 2 100s, which is 200. We have 1, 2, 3, 4, 5, 6 10s, which is 60. And we've got 4 1s. So we add this up and we get 264. Okay, so that is one way that you can solve this. Obviously, this is not the most efficient strategy. It requires the use of pieces that most people don't have in their houses. But kids learn math best when first being able to hold on to the objects. And so when you're holding on to these objects, it's easier to understand the multiplication. So now we're going to look at and see what this looks like maybe without the actual physical pieces, maybe what a model might look like instead. Okay, so this is the one that I've seen a lot on the internet, and people are talking about how it's a waste of time and how it's awful, and so I wanted to talk about it for a second to show you how it works, and then I want to talk about how it connects to the actual algorithm and help students make sense of what the algorithm does. So you start with a box, and you're going to split the box, because we're going to pretend that this area of this box is a 12 by 22. So there would be a 12 at the top, and a 22 on the side. So we're going to split this, maybe this away, and we're going to call the pieces 10 and 2 on the top. Let's make a better line here. Okay, we're going to split them across the midways, and we're going to make a 20 and a 2. So I'm going to rewrite some numbers here. So instead of 12 on the top, we've got a 10 and a 2. Instead of a 22 on the side, we've got a 20 and a 2. And so we're going to be doing some multiplication here, and it's going to look similar to the boxes that we made with the pieces. So this top left box is a 10 by 20, which is 200. The top right box is a 2 by 20, which is 40. The bottom left box is a 10 by 2, which is a 20. And the bottom right box is a 2 by 2, which is 4. And so you add those things up and you get 264. Okay, so now what we're going to do is we're going to take this model and we're going to talk about how it relates to the algorithm. So here's the model we just solved. And so I'm going to show you the algorithm and how it kind of relates to this model and the pieces that are there. So we've got 22 times 12. I'll use the standard algorithm, which is the multiplying here. First step that you would do in the algorithm is you do 2 times 2. That 2 times 2 is 4, obviously, but where that is represented on our model is right in here. This is a 2 by 2 piece that we have to do. Okay, next thing we would do would be 2 times 2 again, but we're multiplying this 2 times 2, which is 4 again. And so I'll go ahead and put my 4 here. What's happening there, though, is that 2 that we multiplied with on the first factor is at 10, right? So it's 2 tens times 2, which is 40, which is right there. That's why this piece right here is 44, and this thing right here is 44. So in the algorithm, the next thing you do is you put a 0 down here because, you know, for some arbitrary reason that not everybody understands. And then you would multiply each of your top 2 numbers times the 1. Well, the reason you're putting the 0 there is because this 1 is really a 10. And so when you're multiplying 22 times 1, if you put your 0 there, you're really doing 22 times 10. And so you do your 2 times your 1, which is 2. This is this place right here because it's 2 1s times 1 10, which is right here. And then your second 2 times your 1 is 2 again, but that is 20 times 10, which is this piece right here. So I'm going to go ahead and put my 2 numbers here. I got my 2 and my 2. I'm going to add them up. I get 264. No matter how I do this, I get the same answer. So why do the model at all? This is the real question. And I think the model is really important for students to understand the why and the how of this algorithm working. The thing that I see a lot with students is that students mess this algorithm up and they're not really sure why they mess it up. The biggest thing they do is they forget to put the 0 here. And rather than just drill them with 80 more questions, it's really a concept thing. Why are we putting the 0 there? Because when we're multiplying these 2 2's times 1, it's a 10, and so that 0 has to be there. It helps them understand, or this model here helps them understand how these pieces fit together. And understand, when teachers are asking students to do this model, it's not because they expect them to do the model forever. They're having them do the model to help them or help prepare them to do the algorithm, which is this piece over here. And eventually, you might even not use the algorithm. Maybe you would do something like 22 times 10 and 22 times 2, because 22 times 10 by itself is 220, and 22 times 2 is 44, just like these pieces here, but it allows you to do that piece in your head. Without having that conceptual understanding, it's very difficult to do that. So this has been modeling for multiplication. Hopefully that sheds some light on this situation. The next video will be modeling with division, which is a little bit harder.